Welcome to Summarize Science, where we break down fascinating new research. You've probably seen the incredible images made by AI like Stable Diffusion and Midjourney, but what if that same technology could be used for more than just art? A new paper titled Visual Diffusion Models Are Geometric Solvers shows that these AIs can tackle famously difficult math problems. The core idea is revolutionary. Instead of feeding the AI equations, the researchers treat geometric problems as image generation tasks. Essentially, they show the AI a picture of the problem and ask it to draw the solution. Let's look at their first test, the Inscribed Square Problem. This is a century-old puzzle that asks if every possible closed loop, or Jordan curve, has 4 points on it that can form a perfect square. It's still unsolved in the general case, but this AI can find approximate solutions for any given curve. The model starts with pure noise, like TV static, and over a series of steps, it denoises the image into a clear shape representing a square whose corners lie on the given curve. And because it's a diffusion model, starting with different random noise can lead to discovering different, unique squares on the same curve. Next, they tackled the Steiner Tree Problem. Imagine you have a bunch of cities on a map and you want to connect them all with the shortest possible road network. Finding the absolute best layout is incredibly complex, a class of problem known as NP-hard. The AI was conditioned on an image of the points and generated an image of the optimal tree structure. The results were astonishingly accurate, producing solutions that were over 99% as good as the mathematically perfect ones. The final challenge was the Maximum Area Polygon Problem. Given a set of dots, the goal is to connect them to form a single, non-overlapping shape that encloses the largest possible area. Again, this is an NP-hard problem, but the visual diffusion model produced high-quality solutions that were nearly identical to the optimal ones. Even when the AI solution wasn't perfect, the difference in area was usually tiny. So, what does all of this mean? Let's recap the key takeaways. First, this approach is incredibly versatile. The researchers used the exact same AI architecture for all three very different, very hard problems, only changing the training images for each task. Second, the AI seems to reason visually in a way that mirrors human intuition. If you look at the denoising process, the AI first forms a rough, blurry outline of the solution before progressively refining it into a precise answer. And third, its ability to find multiple different solutions for problems that allow them is a huge advantage over traditional solvers that might only find one. Looking to the future, this work creates a fascinating bridge between the world of creative, generative AI and the world of logical, mathematical problem-solving. It suggests that a whole new class of scientific and engineering challenges could be tackled by teaching AI to see the problem and simply draw the answer. It's a powerful demonstration that sometimes a picture really is worth 1,000 equations. Thanks for watching this episode of Summarize Science.